Welcome to our Quick Start guide for the DYNA4 vehicle and environment simulation. My name is Suzanne and I want to give you a brief hands-on introduction to DYNA4 to make you familiar with the basic usage of DYNA4 and get you started for your simulation projects. After you installed DYNA4 and activated your license with the Vector License client, you will be asked to configure DYNA4 at the first start. Our models are based on MATLAB Simulink. Therefore, you need to provide the root folder of the MATLAB installation you would like to use. Next, you can specify a location for your simulation projects. Our example projects will be stored here, and this will be the default location for your own simulation projects. You also need to specify a location for the DYNA database. The DYNA database is a central repository where simulation models and parameter files are stored to be used among several simulation projects. Before we start with a hands-on introduction, let me introduce the main concepts of DYNA4. All relevant data, specifically the Simulink models with their associated model parameters, the tasks and scenario definitions, the simulation results and functions for pre- and post-processing, are represented and managed in projects. Think of them as dedicated folders. Simulink models are set up and supplied with parameters through specific edit functions. The combination of a model with its parameters, the model data, is called model configuration. This concept makes it easy to manage variants of the same model with different sets of parameters. Say, you can use the same model for a sedan and station wagon, but they differ in their parameter sets. After defining your vehicle model, one or more scenarios for the simulation can be defined. Each scenario describes the environment, mainly road geometry and surface properties, the definition of the maneuver for the vehicle under test and its surrounding traffic. One or more scenarios can be combined together with functions for pre- and post-processing in a simulation task. Tasks can also be used for the definition of parameter variations for an easy setup of automated simulations. It is important to know that hitting the Run button in DYNA4 will lead to the execution of these tasks. Now that I gave you a brief introduction into the general ideas and concepts of DYNA4, my colleague Peter will take over.
Hi, I'm Peter. I will demonstrate hands-on how some of the things that Suzanne told you about are actually done in DYNA4. Please start DYNA4 now, if you didn't do it already. Here you see the graphical user interface of DYNA4 that might look and feel familiar to you if you have worked with Eclipse before. The user interface is structured in pages, or how we call them, perspectives. Each perspective addresses a specific step for setting up and performing a simulation. Each perspective contains several sub-windows, the views. It is possible to toggle between the different perspectives here on the top right. Once you feel comfortable with using DYNA4, you can adjust the perspectives to your own needs by changing window sizes, adding other views and so on. Double-clicking on one of the tabs will maximize the view. Another double-click will shrink the window to its original size. For now we will stick with the standard perspectives of DYNA4. You can always go back to this default with a right-click on a perspective tab and then selecting Reset. The Project Navigator view on the left is available in most of the perspectives. It lists the available simulation projects. Double-clicking a project will open it. Please open the Project Demo Studio. We will use this basic project in this tutorial, because it has the fewest license requirements. You can later use our other demo projects that are more relevant for your use case and your license configuration, say vehicle dynamics or driver assistance. After you opened the Demo Studio project, you will see the available model configurations and the tasks that can be executed with these model configurations in the project overview perspective. Here, we use a basic vehicle dynamics model and a simple full throttle task. On the model data perspective, the model data of the currently active model configuration can be edited. That means that all parameters regarding the vehicle under test can be found and edited here. The model data is structured in components and subcomponents according to the physical structure of the vehicle model. You can browse through this structure by clicking on the components. The components themselves contain one or more modules. Each module contains a file with the corresponding parameters. To view or edit the model parameters, select a data file and double-click to open the content in a graphical editor. The modifications can be saved into the existing file or as a new file with a new name. All data files are stored in the project. Let's look at an example. Open the vehicle component and click on the subcomponent of the chassis. Double-click the parameter file of the single-track module. MATLAB will open if you haven't already opened it. You can now change the weight, let's say to 1,500 kilograms. Now click on Save As in the toolbar and save the parameter file under a different name, say Compact Van Heavy. The new parameter file will automatically be used now. An asterisk at the component indicates that the composition of the component has changed. On the scenarios perspective, the available scenarios in the project are listed. The content of the selected, currently active scenario is shown in the Scenario Components view. As for the vehicle parameters, select a data file and double-click to load the file content to a graphical editor. As an example, I opened the longitudinal maneuver description of the vehicle under Test. Here we can see that we have different phases and that after a short startup phase, we simply set the accelerator pedal position to 1 for full throttle. You can make your changes here and save the modifications just as explained before with the model data. When we go back to the project overview perspective, the available tasks are listed. The task Full Throttle is currently selected for execution as the active checkbox indicates. For fastest execution, select DYNA4 Windows Executable as your simulation target. To run the simulation with the selected task, click the Execute Tasks button in the toolbar. The animation window starts up automatically and loads the environment settings. The animation will show the computed vehicle motion at runtime. It is possible to change the perspective and camera settings interactively with your mouse. After the simulation is completed, the results will be shown automatically as time series plots. The results, which are displayed here, as well as the animation data are stored in the project together with the simulation parameters. And, of course, it is possible to view results or the animation at any later point in time. One more remark on the simulation target selection: to execute a DYNA4 Windows executable, the Simulink model must be compiled and you need a DYNA4 run license. Without a DYNA4 run license, you can only use the slower Simulink target. This will directly execute the simulation in Simulink's normal mode and is ideal when you're in a phase of making frequent changes to the Simulink model. Let's select Simulink for the target now and hit the Run button again. The Simulink model will open and the simulation will start. If you have a look at the Simulink model, you will see the blue component blocks. These 3 on the bottom are scenario components. The 4 above are model components. They are directly linked to the DYNA4 user interface. Let's look at an example. Here is the vehicle component. Double-click on it to open it. You will see all of its subcomponents, like the chassis component. Double-click on this component to get to the next lower level. You will now see the single-track module. Another double-click opens the mask of this module and here you can see the parameter for the vehicle mass, which we increased before. This parameter change was done in the DYNA4 user interface and did not require a recompilation of the Simulink model. However, if you make structural changes to the Simulink model, you need to recompile it, in case you want to execute it faster. To do this, select the target DYNA4 Windows executable and click on the Build button. If you want to compile for other targets, click on the Gear button to configure the drop-down menu. That's it from my side for now.
Thanks for this hands-on introduction, Peter. You now got a first glance on the functionality of DYNA4 and performed your first simulation. We hope you enjoyed this quick start guide and that you feel prepared to start exploring DYNA4 and kick off your own projects. If you have any further questions, don't hesitate to contact us. Thank you for your attention.